All right, hello everyone. Welcome to another webinar hosted by Seek Thermal and Andy Starnes of Insight Fire Training. We have Andy, who brings over 30 years of experience from his career as a battalion chief in Charlotte, North Carolina. So Andy, thanks for being here today to talk with everyone about ways to improve Fireground size up and use thermal imaging for faster and safer tactical decisions. If you have any questions, please type them in the chat. We'll do our best to answer them in a timely manner throughout this webinar. And with that being said, I hope everyone enjoys it. And Andy, take it away.
Okay, thank you, Jordan. So my name's Andy Starnes. I've been in the fire service now approximately 34 years. Started as a young person chasing my father around, got involved in Sandy Ridge Volunteer Fire Department, got a career at age 22, retired 2023, started a company called Insight Fire Training in 2015. The background started actually through Project Kill the Flashover, where I got my actual start in thermal imaging in 2010. I'm blessed to work with a large thermography certified veteran fire service cadre who are a brilliant group of individuals. We train firefighters across the U.S. and internationally, and we developed the first collegiate-based thermal imaging certification for firefighters through Western Kentucky University and peer-reviewed by Kentucky Thermal Institute. My wife and my daughter and I all live in Shelby, North Carolina. We travel quite a lot, but they are my world, my faith, my family, and the fire department. I share that with people because my motto is I work in the dark. And you see through the eyes of a thermal imaging camera and properly interpret that data and use it to get home. And I want you to have a family to get home to. So we've started working in nonprofits to assist firefighters with all the issues they face in behavioral health, marriage, family, suicide, things of that nature. We are a board member on Fire Alarm Task Force, and we just recently formed our own nonprofit in April of this year. You'll see more of that in the future. So let's talk about what you came to learn today. Thermal imaging and size up. Why is that a popular topic, or why should it be a popular topic? Well, first of all, one of the most important tasks on the Fireground is size up. Consistently, whether you read Mayday reports, NIOSH reports, near miss, you will find that we continue to not complete or get a full 360 or size up on the building, and that's listed as a contributing factor for injuries and deaths and near misses. So thermal imaging cameras, however, have been used to inspect buildings for decades by licensed thermographers, those who understand how to use a thermal imaging camera to find problems in a building that are not on fire. But yet firefighters have failed to implement these devices during size-up operations. Why? Because unfortunately, we train approximately about 20,000 people a year, and about 1% of them say they've received actual hands-on live fire training. So that means the majority of firefighters are not receiving training on these devices other than, here's how you turn it on, read the little number at the bottom right-hand corner, red is hot and they can't see through glass, which is just enough information to get you injured or killed. The good news is with proper training and implementation, we can take these devices and use them to enhance your strategies and tactics on and off the fire ground. And this training is available free online through our YouTube channel in partnership with Seek Thermal. We have produced more free training to date than anyone out there. Please check it out. Use these resources to help you develop your own programs. We understand the conditions and struggles of fire department budgets, and we're here to help. This picture right here is a good example of thermal imaging use and size up post-fire knockdown. We're looking at two different application modes through Seek Thermal. We're looking at TI Basic on the right and survey mode on the left. This is how we get people's attention to get them to understand how to use these devices properly so they don't leave a scene and have a rekindle or worse. This is a great example of how cameras can help you, not just in size up, but during your strategies and tactics, which size up by definition is an ongoing evaluation of incident priorities from start to finish. This is a very large fire in Gwinnett County, Georgia. Some of my good friends there share some their wonderful work they're doing. This fire is well advanced, and they do a phenomenal job stretching lines and knocking down a large amount of fire, exterior and interior. And this short 3-minute video, which I've shortened down even shorter than that, shows firefighters stretching lines to the Alpha Division and the Charlie Division. And I want you to look at how much heat is visible on the Alpha side. A lot of people would wrote this structure off, but not these firefighters. They're going to knock down a large amount of fire on the Alpha side. They're also stretching a line to the Charlie side. You can actually see heat reflecting off the fire truck. This is the Charlie side C Division. You see a wooden deck. You see fire extending to the Charlie side and first and second floor. There's a window that's actually failed where firefighters are actually stretched and they hunt intake and flow water into that intake. And you see the convection currents on the front of the building still pushing pretty hard. But once they start flowing water into this window, what you see from both sides is they knock down a large amount of fire. That center heat signature is an example of something we're going to talk about later called thermal bridging, heat transfer through the actual interior wall to the exterior. And once he starts flowing water here, you see a tremendous difference in the heat signature start to diminish. The colorization starts to go away. We see thermal bridging around that door showing heat coming through the door right there in the center of the Charlie side. We walk back around. I want you to look at this. One of the things we talk about in this program is when we finish our 360, we compare it to our initial view. What has changed in that short little time that we did this walk around? These guys did a phenomenal job of knocking down a large amount of fire. They still have a lot of work to do, but they went from turning this into a parking lot to possibly rebuilding portion of this building, thanks to their aggressive work and being able to use the camera to see, are they making headway or not? But this comes down to fundamental tactics of the firefighters being fundamentally skilled. And this is a great job by them. So I want to highlight that. This is just one example of using the camera correctly. So what does NIOSH say about common themes when we talk about line of duty deaths? A lot of people get upset reading NIOSH reports because, for good reason, we keep killing firefighters the same way and it reads like a broken record. And they say, well, NIOSH is not doing anything. Unfortunately, it's not NIOSH does not do anything. NIOSH only investigates 40% of actual line of duty deaths on the fireground. I need you to think about that for a second. 40% are the only ones that are investigated. We don't even know the true numbers, number one. Number two, they have to be asked to come in to investigate it. And number three, we are the ones who are not holding ourselves accountable, not NIOSH. It's not their job to fix us. We need to fix ourselves. Accountability starts with us. And this is what they've commonly pointed out that no one likes to hear. We like to enter a building without knowing the layout or fire spread. We could simply do that by a size up in your initial scan. We also underestimate the structural stability of a fire or the building or the fire's intensity. That could be also potentially assessed by a thermal imaging camera. We can't look at the exact structural integrity of a building. We know that for a fact, but we can see signs of failure. Another big issue is a lack of crew accountability in the ICS structure and communication, which is a consistent theme. I understand my friends get frustrated by the consistent reports and the consistent recommendations. But ladies and gentlemen, that falls on our shoulders, not NIOSH. Here are three examples that I would challenge you to look up. Illinois 2019 residential single family fire, where there's an incomplete size up. They made 270 degrees, but no communication. The captain was killed. Missouri 2022, two-story brick home. Detailed size up reported, but the risk was misunderstood or not properly interpreted, resulting in a firefighter fatality. Indiana church fire. We should treat church fires different than a residential fire, ladies and gentlemen. Size up did not consider critical hazards, which resulted in a firefighter fatality. I have more friends and more people who share information with us, and we consistently see that firefighters are not using TICs during size up or even finishing a basic size up because they're so focused on getting it done fast, they're doing it incorrectly, incompletely, or getting someone injured or killed. There's a difference between being fast and wrong or being fast and efficient. Take seconds and win minutes, ladies and gentlemen. It's what Chief Mike Mitchum taught me from the Charlotte Fire Department. And I want you to think about this as we move forward. Thermal imaging and size up is not new. This has been going on for decades in the thermography industry. Thermography is the art and science of temperature and heat interpretation through the eyes of either a quantitative camera or a qualitative device. Firefighters use qualitative devices that don't see temperatures accurately, but we look for anomalies and things that can assist us in our strategies and tactics, where the fire is at, where it's going, and conditions that may help us, such as infrastructure and layout, and identifying potential locations for victim, and in some cases, even seeing the victim. But these people have been doing this for a while. They've been sizing up block walls, looking at buildings for air infiltration, exfiltration, looking at electrical systems, whether it's breakers or systems where high heat's coming through, like transformers, substations. Energy loss, is your building energy efficient? HVAC, industrial thermologists, residential ones. This is not new, yet we have not consulted these individuals to learn from them. That is why all of my instructors or a minimum of level 1 thermography certified, because in order to use a thermal imaging camera, you got to understand physics and infrared science first. These are some things that these individuals do for a standard home that's not on fire. I want you to think about it. They can identify electrical problems in your home, construction defects. They can identify where air is leaking inside and outside your home. You should care about that one if you care about saving money. Roof leaks, insect and rodent infestations, voids in your insulation where your heat and air is leaking out. Plumbing leaks, that's a big one. Moisture leaks in general. Bad windows. You're like, what? You can actually see a problem in a window? There are window thermographers who actually see patterns on windows indicating the inner gas has gone bad. I can show you a window during a house fire where you see heat transferring from the back side of it, a double pane window, and you're like, why is it doing that? Because the inner pane has failed and you're seeing movement indicating transfer, or the inner gases are starting to heat up to the point that the inner pane fails. These are things we've seen over and over and over where we translate industrial thermography concepts to fireground tactics. So what can you as a firefighter detect with a fire service TIC? Because to their point, many of my friends who argue with me affectionately, a fire service TIC is quite different than an industrial TIC. Doesn't have some of the features, settings, and is not as precise. And sometimes we don't have the wonderful image clarity that our friends have in the industrial world. So here's some things we can see. Fire location and severity, direction of which the fire is going. Those two are critical. Here's one that most people overlook. Cold areas, isolated areas. We tell the public when they go to sleep at night to close the door. You could have a building 60, 80% involved and have a room completely isolated that you could take a window from the outside and rescue someone and still make the rescue even though you may lose the building. You could also identify cold areas for direction of fire spread. You can see structural components in some cases. You can see whether or not your crews are being effective with their tactics. You could see potential collapse factors. And here's a big one. Buildings are so close together, you could see potential exposure detection as far as heat transfer and the fire is about to light that building off, and more. This is from Captain Joey Baxa, one of my lead instructors, showing a basement fire after knockdown. Look at the heat signatures he sees, what we call thermal bridging from the basement going up. You can see where the platform construction is. You can see heat transfer from the bottom to the first floor. You can see thermal bridging indicating the roof joist. You can see all that heat on the bottom transferring through that structure, moving around as we walk towards the front of the structure. And you can actually see it around the bottom where the seal is around the foundation, where it's coming through that. So if you look back to the very beginning of this video, you can see a large amount of heat transferring from that bottom floor up into that first floor and transferring in between that first floor and second floor in that interstitial space known as the platform construction. You can see signatures around the windows. The windows are showing white because they're heating up because this building is unoccupied at this point and it's full of smoke and heat. When we start to learn what thermal signatures look like or heat signatures look like, we can use this to help us with our strategies and tactics. This is just a still frame shot of that backside where you can see that. Here's the problem with this. The majority of firefighters completely disregard, ignore white spots in a building because they do not know what a non-uniform heat signature means. Here's some food for thought for you and some facts. If I'm a building thermographer, a building science thermologist, or someone who inspects a building, all I need is an 18-degree Fahrenheit delta T or temperature differential from the inside of the building to the outside to produce an image on an exterior surface indicating a problem. There has to be enough contrast from the inside to the outside with the camera's thermal sensitivity and resolution to pick that up. If it's only a few degrees off, 2 to 4 degrees, you're probably not going to see it. You can have an insulation gap there and they wouldn't see it. But if they have at least around 20-degree temperature differential, they're going to see it. Now, if they can see that at around 18 to 20 degrees temperature differential, would you agree with me, friends, that when a house is on fire, there's going to be more than an 18 to 20 degree temperature differential from the inside to the outside? Some of you live in some places in the wintertime, it's dramatically different than 20 degrees difference. Here's what helps us. High resolution TICs with investigative mode color palettes. You look at an Attack Pro or a Fire Pro 300, they both have 320 by 240 resolution, which is the minimum you should have. And they both have something called survey mode, which colorizes the problem at 150 degrees Fahrenheit or 65 degrees Celsius for my friends overseas. Another thing that needs to be considered is part of your size up is not just the exterior. Interior openings should be scanned to confirm or contradict where this fire is at or what you think is going on. That could include your firefighters making entry and checking just inside to look for victims. Like Firefighter Rescue Survey teaches us that 12% of all fire victims are found within so many feet of an egress point. We need to look. As you're walking around, you can check crawl space doors. You can open doors and look, but please don't leave them open and create an uncontrolled flow path. Firefighters need to understand that opening a door or a window is ventilation, and we create flow paths. We need to maintain and control the flow path and not make the fire worse. So the very first slide gave you 3 points of what we're going to talk about today. Here are your 3 points. We're going to talk about the methodology of TIC use and size up, interpretation of thermal data and size up, and contraindications. Make this really simple. We take an 8-hour presentation and do it in less than 1 hour, because I want to give you experientially relevant data that hopefully someone who watches this webinar can use at the very next fire if they start practicing. 1, 2, 3. Let's start with the size up overview or the methodology. Number 1, your standard size up concepts apply. Before you pick up a camera, you have to be fundamentally sound and use your experiential knowledge and skills to assess the building. This is a bank fire in Cherryville. I've lived there for 20 years outside of it, that they're burning down to build a new building. This is a large amount of fire. Many people would not use a TIC when they walk around this. You would be surprised that there's still one cold spot left in this building right before it goes. We do our 360 and look at the building with our eyes, and as we go around, we pick the camera up looking at each area A, B, C, D. If you are a company officer and have the fortune of having a crew with you, you send a crew to the primary egress points to check it. Why would you do that? Because they're running away from the fire, you're going towards the fire. As Kyle Romga says, Indian companies don't find victims, they discover them. We are going to intersect at some point. So have them stage there, get ready, and if you're walking around, as Chief John Lightly says, hey, bring that line to the Bravo Charlie now, he may see something that indicates a better access point. As you're walking around the building, Alpha, Bravo, Charlie, Delta, or whichever way you get to go based on circumstances, we're going to scan the building low, middle, high. I was taught to scan high, low. We don't do that anymore, and we don't even teach that anymore because it's problematic behavioral wise, scientific wise, and causes major problems. A lot of firefighters who look up first don't look down. They miss basement fires. They miss it's a balloon frame structure. They miss thermal cues. Building thermographers or thermologists, they size a building up or scan it from bottom to top. They start from the rim joist and work their way up. They're looking for the coldest area to the hottest area and looking for that contrast and potentially seeing leaks where the problem even started. As we're walking around, as I mentioned earlier, we're going to check openings as we go. And when we finish our size up, this is extremely important. Make sure you compare your initial view versus your completed view. As the fire intensified, got worse, what has changed? Because if it changes that fast, you better be ready. Here are some examples of the thermal breach. Well, I mentioned this earlier. Thermal bridge, also known as a heat bridge, is an area or object which is significantly higher heat transfer or surrounding materials, resulting in overall reduction in thermal insulation of the object or building. In layman's terms or firefighter speak, it is a bridge from the inside of a structure to the exterior where the energy is being transferred or leaking out. Think of the building as a big box with an inside of an envelope, and anywhere that envelope is thin or has a hole poked in it, or breach in that envelope, or where you didn't seal the envelope well, there's potential for something to get in and get out. In these 3 examples, I've got pictures from some of my good friends in the Georgia area. Webb Marshall is one of them. That you're seeing a roof vent in the picture 1 that's heated up. We have a fire on the first floor, but in the attic, we're already seeing heat transfer through that roof line on several different pipes, one of which this is one of what they call whirlybird roof vents on the picture on the left. This is another picture on the opposite end, away from the structure in the center, where the heat is transferring so much into the attic that we're seeing thermal bridging through the siding, and that in that attic space where we can actually see the wall joist, we can see the siding, we can see that it is building up with heat. And the last one you can actually see spacing between the roof joists. This is very important for my friends who do vertical ventilation, working on roof, or need to just identify the structure as far as is the building, 24 on center, 16 on center. Do I have an attic fire? Or from an incident commander perspective, I can see as heat's transferring from one side to the other if they're making good headway. These are examples of thermal bridges. This is my favorite example of a thermal bridge from Chief John Lightly, one of my instructors. This is a basement window, a single pane glass. Whether we had burned through the floor or a fire in the basement, you would have to interview him to get the full story, which I'll show you his video here shortly. But we're seeing heat transfer through that glass because single pane glass does not stop infrared energy. Windows are a window of opportunity. Certain windows will show heat much easier than others, such as single pane glass. Double pane glass, not quite as easy, but we will see energy around the edges of the frame where the caulk fails. And in many cases, you will see the top sash fail and drop before the actual glass fails. We'll see the interior panel fail and see movement or heat transfer from the inside of that double pane glass before we actually see the entire thing fail. You have my friends who are in Florida or overseas, have triple pane glass or hurricane windows with Lexan on the outside. You may not see anything on the window itself, but around the framing, you may see it on the top. You add that with stucco and more insulation, you're going to see a lot less heat transfer because they're very well sealed, and you're not going to see as much thermal bridging, or if you add that to an 8-inch block wall. Commercial windows, on the other hand, you can have older ones that are single pane that could show energy quite easily, versus newer ones that could have security glass, could be very well reinforced, which could hide heat from you. However, if we know what we're looking for, when we go to look at it, we can recognize those patterns and understand when we have significant heat transfer of something that should not be there in the first place. These are examples of a home made simple. This would be my wife's dream home. It has lots of little triangles everywhere. She likes cupolas, dormers, corners, gables. All those things make homes more expensive. So we have a chimney, we have a cupola, we have a dormer, we have a skylight. Then you have gable vents, you have attic vents, you have a powered attic vent, you have pipes for their vents. Those are being replaced in many homes with interior vents. I don't know if I'm really crazy about that. Bay windows, we have crawl space vents, and friends up north and northeast have Bilco doors indicating basement windows. My friends in Tornado Alley, underneath that portico you see there, that concrete base, in many cases is a storm shelter. There may be an access point underneath the mat to the front door, or a basement where there is a completely sealed off, almost like panic room there. So these are all areas where we could see potential heat transfer because we have ventilation in some places. Others we have caulking, flashing. We could have rubber gaskets around it, all which fail under fire conditions first. So the building's weakness now becomes your strength. But the only way this is going to work, ladies and gentlemen, is if you start looking at buildings under normal conditions, which is what we call thermal pre-planning, and then start comparing that when you have house fires or training to see the difference. And some of those areas of interest I want you to focus on are what we call punctures or breaches in that building's exterior, such as windows, doors, vents, pipes, drains, anything like that. Look at those first when you're scanning, unless there's something obvious. Then there's geometric thermal bridges. This is where areas of the interior touches the exterior and causes significant heat transfer. This could be a wall joist, could be a metal or steel I-beam or stud, could be stairs, ductwork, shafts, things that you would not think you would see that you actually. The most important one you'll see is called non-repeating thermal bridges, areas of heat visible that should not be there. Let me say that again, it shouldn't be there. Under normal operating conditions, the building should not show a heat signature of 500 plus degrees coming out the dryer vent. You shouldn't see the Charlie side crawl space vents lighting up, pushing convection coming out of it. Those are non-uniform. You shouldn't see little wispy like patterns across the second floor windows. That shouldn't be happening. But that indicates severe heat within the structure. You need to pay attention to that. This is building thermology applied to firefighting. To make it really simple, this is how we help you see that. You look at a building, you need to think about these things that will help you as far as how the camera will interpret that data. This is a picture from Chief John Lightly. This is as they're attacking this house fire. This is the front porch view. We have different than the outside of these buildings. Could be wood, could be metal, could be vinyl, could be brick, could all kinds of different surfaces. Then we're looking at temperature, not exact measurements, but abnormalities, right? We know fire, but we look for extreme temperatures or patterns that shouldn't be there, which we'll get to here in a minute. And then insulation properties. Is the building well insulated, like a newer home, green or LEED certified, or is it an older home that's not well cared for or not well insulated? Or when you're dealing with metal buildings, mobile homes, things of that nature, where heat transfer is very easy to detect. Even under normal conditions, you can see problems in the building. And then we look for those obvious cues of thermal bridging all through the kind of camera we're using, which needs to be a higher resolution camera, with preferably an investigative mode that helps us see these problems earlier and not late. This is our STIC acronym that we use in our size up curriculum. These surfaces could be various things, but we're giving you some examples as we move through it. Wood siding, metal, brick, vinyl all emit or absorb or reflect heat at different rates. They hold heat longer. That's based on emissivity and thermal capacitance. Emissivity is the ability of an object to emit, absorb, or reflect heat numerically between 0 and 1. Thermal capacitance is how long something will actually hold that heat once it's heated up, and how fast that occurs, which is R value in firefighter speak, because we all understand when you insulate your home, R80 is better than R13. The higher the number, the higher its ability to resist heat loss. So if you're looking at something that has a very, very low R value, so on a surface, it will show heat sooner for you to do your size up and indicate a problem within the structure. Let's look at wood. This is a great picture from Chief John Lightly. Wood actually shows heat quite well because wood is porous in nature. Plus, wood is harvested when trees are young now versus older homes, tighter grains, they harvest them from older trees. We can see a window boarded up here. We can see a large amount of heat underneath this porch. We can see how this wood is severely heated, and wood actually begins to deteriorate around 340 degrees to lose its strength. It's not falling apart, but it could start letting go of things such as nails, gusset plates, and things of that nature. So if you're seeing red underneath this porch, which is 850 to 1200 degrees on the SEEK thermal imaging camera apparent temperatures, you should expect that that's not going to hold up much longer, or it's going to fall on your head. So when you hit it with a straight stream, don't be surprised when it falls down. It's doing some major damage to the wood's ability to hold on to things such as nails and components, especially an older home that's been there a while, depending on the thickness of the wood, the density of the wood, the moisture, and things of that nature. You look at this video from Chief John Lightly, one of my lead instructors. He's walking around a well-involved structure. You're going to see a couple of things that's very important. Large amount of fire, number one. We're going alpha delta first here. We're going to look at the delta side. We're going to scan low to high. There's that basement we just showed you a picture of. That's really important. That is one of the number one cues missed by firefighters in Fireground size up. If there is a clue that there is a basement, because some houses do not have basement windows or vents showing there is one, you would look for this or heat transfer around that edge, indicating something's going on underneath that house. Could be vents, basement crawl space vents that are lighting up, could be window wells, a number of things. As we walk around, you'll see more heat. As we start to transfer, looking from low to high, he'll look up. Notice there's no delay with mixed gain mode. He's seeing a large amount of heat pushing to the Charlie side. There's still a few spaces in that back corner that they could make entry, but the majority of this building, the first, say 60, 70%, is well involved, showing heat transfer from the basement, moving up through the balloon frame to that second floor and above into that attic space. This could be a 2.5-story wood frame. You'd have to get him to give you the full details. But you also see on this side, we have a bay window with a basement door directly underneath that window right there. And we're seeing thermal bridging on those back windows, indicating that back corner, that BC corner, still has some survivable space in that area, but your second floor is well involved, and this thing needs an aggressive water solution to knock it back. And understand that you could go through that front door and end up in the basement, not by choice. So make sure you get a good size up. Look at this. This took less than 60 seconds for him to make good decisions about where his crews would go. This is an example of Chief John Lockley's work where the crews have started a fire attack. This is the initial start of his 360, And the second picture is the finish of the 360. Notice the difference and the diminishing temperatures. What does that tell you as far as the fire attack, the suppression efforts, and what the crews are doing? Things are getting better, at least in this area here. May not be the same in the rest of the building, but we can still see where we need to go back and cool surfaces of this area. Keep in mind, you're seeing surface temperatures. There could be significant heat, but hidden behind siding, vinyl siding, aluminum siding, fiberboard siding. That's a mean one. That hides some stuff from you. Extremely good insulator. That's why it's so darn expensive. So this is just an example from one of our instructors who does this on a regular basis. We talk about vinyl siding. It covers more than 35% of all homes in the US. You don't see it in some of the higher heat regions, such as Arizona, New Mexico, because it actually softens at 140 degrees and starts to sag. Even though they say it's not flammable, it actually starts to fall apart and melt and trail fire up the side of it at around 200 degrees. There's been reports of homes being set on fire because the neighbor's house is reflecting energy from their energy efficient low E windows onto their house and melting it. It has an emissivity of 0.9, which means your camera is calibrated at 0.95 to 0.97, which is very good insulator, a very good emitter of heat. So we can see this quite well with our camera. This is a different camera here where I've done a 360 after the fire is extinguished. And I want you to see what you can see when I talked about the geometric thermal bridges that you can pick up. This is after the fire is extinguished during what we would consider an overhaul period where we're waiting, start to prepare to do overhaul before the arson investigators get there. Check this out. See that now? Stay opposite, stare, back, it's awesome. So if we just look at this house under normal ambient temperatures at this point, we can see signs of the stairs, wall joist, a right angle return at the top, which is HVAC, platform style construction, a lot of the information that helps us that's not necessarily about the fire itself, but the building. So thermal data is really big deal for us to capture this on our walk around our initial size level. When we start talking about brick, however, you've got veneer brick, which may be a little easier for you to detect heat signatures through. Then you got true brick, which could be 8-inch thick or even thicker. That's not going to be as easy to detect heat transfer. However, if it's older brick, 50 to 100 years old or greater, if the mortar's not been repointed, you start to see signs of failure. It's just basically sand at that point. You see cracking. You can see heat pushing through that, which is a bad sign. You can also see things like the Death Stars, the metal ties, where they pulled through the building. That's also an interesting area to look for heat transfer. You can look where they bricked up windows with different type of brick. It's a different density, a different type of clay. It'll show up differently. You can pick that up pretty easily. You can look up and see a lot of things on a brick building that you wouldn't think you'd be able to see if you'll just practice scanning it. This could be the same on block buildings. You can see reinforcements. You can see where they poured concrete or there's metal I-beams in there if you will just stand back and look at it. I will tell you, if you're looking at the sunny side of the building, you're going to be disappointed under non-fire conditions because of solar loading. The sun will heat it up and not be able to let you see contrast quite as well. We talk about metal. This is one of our training burns in Stallings, North Carolina. And you can actually see as we pick up our Seek Attack Pro here, we can see that telltale pattern first on the side of the burn container, going from low to high, looking like half of a V, like you see what an arson investigator looks for. Keep that in mind. And I look for fire location, I look for convection, I look for colorization, and I look for descending thermal layer. Look at this. Interesting. Now, this is where the Facebook safety and real world comments come in. They go, you can't do that on a building. Buildings are not made of containers. Number one, got bad news for you. They're building buildings out of containers across the US. Number two, there's tons of buildings that have metal on the outside of it. Number three, this is a rail car in Kern County, California, from one of my firefighters who teaches for us, Sam Adams. Look at this and tell me if you can't see significant heat through it, through the Fire Pro 300 before they even open the doors. Got heat transfer, convection currents coming out of the container. And we got a strong thermal bridge pointing, indicating high heat inside of here. He uses the camera to direct his string to knock down the fire from here, like a sniper spotter mentality. All before they open these doors, they were able to identify how much heat, how much fire is inside of this. These are just interesting ways you could do this. There's been several incidents, sadly, across the U.S. involving rail cars and involving primarily tractor trailers, where firefighters are not sizing these up and opening doors before they realize it's too late. If you see a box car or a tractor trailer that has significant heat, you've got smoke pushing, be careful in ventilating something like that, because it could go horribly wrong for you, especially if you're standing in the presence of those vent points. It would be where a piercing nozzle or aggressive cooling from a distance until you could make access to it, because that one is going to possibly have a smoke deflagration or smoke explosion, leading to terrible results. Just be aware of that. And we don't use the spot temperature to look at those. Keep that in mind. We've emphasized that in our webinars dozens and dozens of times. We're looking at heat, heat transfer, and signs of heat, not for exact measurements. Here's another interesting metal example of a American Airlines passenger aircraft. You can actually see through survey mode in the Seek Attack Pro the reinforcements of the aircraft. You can see the heat coming out of the engines. You can see the heat on the actual brakes. This one has just come in and parked at the main terminal, so the passengers are offloading. If the plane is under normal operation, you can see signs of heat transfer and where the reinforcements are, and a lot of things about the plane that you wouldn't normally see without a camera. A lot of our personnel use cameras on a regular basis. I had the pleasure of 5 years of being an ARF chief and seeing how these devices could be tremendously valuable, even on metal aircraft. ARF is one of the few places of the fire service that got thermal imaging right. When we first started putting ARF thermal imaging cameras on ARF crash trucks, they never put a spot temperature on it because they knew they were looking at shiny metal aircraft. So they were going to get a reflected apparent temperature that was not exact, and it was grossly inaccurate. The fire service would have done well to listen to ARF personnel. From insulation, this is another camera. This is Chief John Lightley's fire. One of the things you need to think about when you talk about buildings is, how is it insulated? Is it insulated well? Is it insulated poorly? And even under heavy fire conditions, it can hide things from you. I want you to look at these heat signatures of these two doors before we press play. So the higher the insulated properties, the more it's going to hide heat from you. You obviously see a large amount of fire in the far right corner and coming out the second floor under that window awning. We know we have fire there. Would you be surprised, though, that you had this much heat coming out of here? And I want you to see what happens when they open this door. This is obviously, this building is a loss at this point, but I want you to see what happens when this door opens. You will clearly see that as we open this door, that we have a large amount of heat transfer thermal bridging behind the door, number one. And when the door is open, what do you think is going to come out of this? Many firefighters act surprised when this occurs. Door open, massive amount of rapid fire development. It destroys that vinyl ceiling, floor to ceiling, 1200 plus degrees, instantly destroys that. I'll back it up so you can see. Just look how much heat's coming out of there. Would you have expected that? Pretty impactful from this to that. Better, worse. Better, worse. Ventilation, ladies and gentlemen, can be from opening a door or window. Keep that in mind. Then we talk about looking for those cues and how well we can see them through insulation. This is from our friends in Denver, Colorado. They had a defensive fire and they were given the assignment to quickly check through the back to make sure no one's in the home. They're going to pull everyone out. The crew stated they had good visibility, but high heat conditions. Notice that in this case, this camera is a dual gain camera. The TIC did not switch to low sensitivity. The first scan was across the middle. The second scan was low. Watch what it picked up. This is pretty powerful because this floor collapsed shortly after they exited. You can actually see heat coming up from the floor if you look closely. Those are nails heating up from underneath. I've looked at my wood floors and the nails are dark. If they're white, I got a problem. I got too high of a heat bill or I got something going on in my basement. There was no signs of a basement on the exterior. And if you also look, you can see a floor register lighting up in the back behind the table there. This is someone who knew what they were doing. They pulled them out, and just within a couple minutes, this floor collapsed. If you're feeling heat and not seeing heat, trust your body. Understand that. The camera has limitations. The UL study on floor collapses and basement fires showed that the floor itself showed a 76-degree measurement when they had over 1,000 degrees below it. That's not too far off for that camera's spot temperature, which we don't look at. But we know that if we look at signs of heat transfer, we can actually get a better assessment of what's going on. Wherever the weak points are, at the bottom of this coming through the floor, whether it's floor registers, whether it's baseboards, you see sagging, look for that stuff. That's why we emphasize scans should start low, or as my instructor Robert Foreman says, always be concerned with the lowest level of fire first. Let's talk about those R values and how that affects you in size up. Anyone who owns a home understands R value because you have insulation in your home. The higher the value, the better your heat and cooling bill is. Look at how low the surfaces are. Masonry is up to 1.1. Wood is slightly under 1. Vinyl siding is actually the best, 2.7. Vinyl, aluminum siding, and fiberboard siding will hide heat from you pretty well. Metal is 0.0031 per inch of thickness. That is the worst insulator out there out of all the surfaces. So it will transfer heat pretty quickly. Also consider any kind of metal connectors in between the interior wall and the exterior, such as veneer ties, any kind of brackets or anything that transfers heat. It will do so quite well. So the lower the number, the faster the heat will transfer. Now, let's think about this from an overall perspective. Chief John Lightly's videos here. This building has collapsed. Even though we're seeing heat on the surface of this, you literally see through that. No, we see heat on top, but you start raking that back, you're going to find a tremendous amount of heat fire underneath it. So all we're detecting is the surface of that and maybe an inch or two underneath it. When in doubt, go check it out. You are not seeing everything. That charred wood and piles actually acting like insulation, such as hoarding fires, like my friend Ryan Pennington talks about. That's insulation. That's a way to hide things from you. Another thing that should concern you would be cellulose or spray-in insulation in your attics. You can have an ember burning underneath that several inches under it and not see it with a thermal imaging camera. When we talk about temperatures we should look for, we know these are apparent temperatures. They're not exacts. So we're looking for data from a qualitative perspective or anomalies, which means what is wrong. Infrared training centers says the anomaly is the deviation of a value or parameter such as temperature. It's not right. Shouldn't be that way. Look at this cable line that Chief John Lightly filmed. This is a cable line, not a power line, that is energized. It shouldn't look like this. He traces it back to the power line. He goes to the house. The cable box is melted. We're smelling smoke. The lights are flickering on and off. For some reason, this cable line has gotten hooked up on something and become energized from the power lines itself. He was able to locate which homes are having these problems. See him just tracing it back. It's like hide and seek, but we're cheating because we now have a tool that allows us to see heat. We never use these devices to define if the line is live or not. We treat all lines as live, but it is a great tool to help you see heat transfer. This is another Chief John Lightly video. This is a short video, and it's not been edited as far as the speed. I'm going to play it in real time, and I want you to see how easy it would be to miss a basement fire, because that's what they have here. Small home, they have a basement fire. Here we go. 2 basement windows, already seen. 3rd basement window, door, a spigot that lit up white on the left. Extreme heat from the basement window to the right. There's the spigot or faucet. There's the basement. I want you to back it up. I want you to see the very beginning, and then I'm going to break it down into small steps for you, why we need to slow down. Window 1 lit up. Window 2. There's also a lit spot there. As we move forward, a little pixelation because of our video. Window 3. There's a 4th window. Bystander, there's your other window that has the majority of the heat indicating where it's most likely located down the stairs to your right. And there's that faucet or spigot, as we call it, lighting up white. I'm going to show you slides broken down here so you can see this 3 slides. The first top left is the very last thing he sees before he makes entry. One of those windows is showing color and convection. There's an abnormal heat signature or non-uniform pattern there. That shouldn't be there. There's another window lit up hot. You can see the second picture on the right where we kind of had a bad angle. Remember, infrared energy travels in straight lines. Once he lines up with this, he got a better picture of it. And the bottom one is as he is walking up, you can see that window well or basement single pane glass is lighting up. It shouldn't look like that. That's an anomaly. That's abnormal. You need to investigate it. Don't trust everything the camera tells you, but you need to investigate it to verify if there's a problem. John Locke also has a brilliant saying, is the camera confirming or contradicting what I think is occurring? I think that's a wise statement we should all consider. The last part of our acronym is, what kind of camera are you using? Is it decision making, or is it a lower resolution, slower frame rate situational awareness camera? You will not see as well with that. What is the resolution quality? You may have a 320 by 240 resolution camera, which is recommended by NFPA, but if it's 20 years old, my 20-year-old cell phone didn't take the pictures that my iPhone 16 does. You need to understand it needs to be up to date resolution, which gives you better pixel quality. And does your camera have a digital overlay? Some cameras make a really good picture by fooling you by having a digital camera, but when you go into a fire and lose all visible light, that digital camera goes away. And the most important part of this, next to fire resolution, would be, does it have an investigative application mode that would help you? Seek offers one called survey mode. FLIR offers one called search and rescue mode. Bullard offers one called electronic thermal throttle. Argus offers one called size up mode. Those are extremely beneficial to company officers and firefighters when they're looking for heat under 500 degrees typically. So when you're in low heat situations, or as my friend Mike Chapman said, use them early or late in the incident, or you're remote from the fire, overhaul, all of those and smells and bells, they could be tremendously valuable in helping you do your job. Just like this survey mode versus TI basic picture, a grocery store fire where someone decided to set some boxes on fire outside of the building up against the wall. This is in survey mode. It is a block wall in the back. You can see the heat on the block wall, the masonry wall. You can see the remaining boxes and stuff that's on the ground that still needs to be cooled down. Watch what happens when we go to TI basic. But be honest with yourself. Would you put water on that wall? Probably not. Because firefighters don't differentiate shades of gray or white very well under stress. Nobody does. Thermographers have the luxury of time. Firefighters don't. That's why these investigative mode color palettes are brilliant to help you. Understand you're seeing surface temperatures. You could have heat transfer through into the inside, or it could just be surface temperatures alone. When in doubt, check it out. Make sure that it's actually what you think it is. And that's also a good example. They're peeling back cardboard and finding even more heat underneath it, because cardboard is a great insulator. Contraindications. You've got paramedic friends out there. God bless you. I'm not that smart. I was an EMT dummy in my whole career. Contraindications is something that causes us a problem. When we talk about size ups, some of those contraindications would be well insulated buildings. You're looking at thick walls, reinforced walls, energy efficient green LEED certified SIP panels. They can all hide heat from you. Masonry walls. Large buildings can have a fire at a long distance from the walls and produce no discernible heat signature. You still have a fire in the building, but they're not near a wall or heating up something to show you a sign on the exterior. Wind or extreme cold can cut temperature measurements dramatically. My friends in Cheyenne, Wyoming deal with some severe wind. So Texas, I had no idea until I spent a lot of time there. Texas is considered a windier place than Chicago. They have more wind or wind-driven events than anybody else. Solar loading, you're talking about just the sun heating up the building. In survey mode in a Seek thermal product, I can see colorization on a sunny day in Arizona. I even saw it in Michigan. That was 150 degrees plus on a asphalt shingled roof, and it wasn't on fire. Reflective surfaces, low E glass, shiny metals can throw you off. And the biggest limitation or contraindication is the end user. If we're not trained, We're putting effort into this, and the only time we're training is when we have a fire. Don't be surprised if you get frustrated by the camera because you hadn't put any work into it. You haven't invested any time into it. So instead of watching random videos on YouTube, start looking at some of the videos we offer where you can see what these buildings look like through your camera. We have the cameras categorized on YouTube from MSA to Bullard to Seek to FLIR, where you can look at them. Now, we don't have everything, but we have over 460 videos that you can watch, including 100 hours of webinars for free. Take advantage of it, okay? Where does Seek come into this whole process, and how can their product help size up as far as advantages, help you as a firefighter? Number one, mixed gain mode is the fastest and earliest colorization technology on the market. Every other camera on the market colorizes by switching from high to low sensitivity, and they do it by percentage of pixels. In other words, they're like a manual transmission. I got to have enough RPM to switch from first to second gear. In a camera, I got to have enough heat, percentage of pixels to hit that point, that breakover point, and then the manufacturer tells you when colorization engages. Mixed gain mode does it pixel by pixel. One pixel shows 150 degrees Fahrenheit in survey mode, it'll colorize, or 302 degrees Fahrenheit in TI basic, it'll colorize. I've had students back up from a heat source upwards of 900 feet. They can still see a small colorized dot. It really helps you in size up. So survey mode is a game changer because it shows it early. I ask people all the time, do you want to see the problem early or late? I always want to find a problem early. I don't know about you, but I like to work smarter, not harder. And mixed gain mode does something that only one other camera on the market keeps up with this. They are the fastest device currently on the market because it switches pixel by pixel instead of percentage. So that allows you to gather information faster, especially if you don't have time to do a slower scan or your scan has to move because you're in a bad place or you're about to get burned. We understand that. Seek Thermal understands that you don't have the luxury of time. Gain change was introduced when we went to dual gain cameras where you had high and low sensitivity, and some of them are faster, and some of them are slower. You need to learn when your switches, when it shows color, what convection looks like. And if you're using a Seek product, you don't have to worry about when it switches. It does it automatically. There is no icon. And just like in this video right here, we can see from the post-fire suppression efforts, we're starting to go in and do knockdown. Survey mode shows colorization early and how much we still have to do in that attic space. That really makes your job easier. This was after the fire's knocked down. Which one would you rather have? 256 shades of gray or other colorization saying, hey, you might want to check this out. And keep in mind, cameras are not a magic wand. You can have heat hidden behind stuff and never see a heat signature. You can have reflective surfaces that can hide from you. But if you're smarter than the device you're holding, you'll learn to use this in an intelligently aggressive way that will help you win on the fire ground and get home to your families. And to help you with that, we have a copy of the presentation here. If you're interested, the left QR code. This is 21 hours of Seek webinars in the center. This webinar will be added, will be up to 22 hours. And this is the YouTube channel I mentioned. Please hit like and subscribe. My daughter's the motivation behind that. She helped me get the YouTube channel going. We're up to 23,000 subscribers. I'd love to do even more. We're going to put up more free content in 2026 that's going to help people even more. So please use these resources. We want to help you. We want to help your firefighters, and we want you to get home to your family. God bless you. Thanks for watching. And this is my contact information. I'll leave it on this last slide and hand it over to Jordan. Thank you, Jordan.
Thanks, Andy. If you guys have any further questions after this webinar, please feel free to reach out directly to Andy or myself. We'd be happy to answer any of those questions that you guys have. If there was something that Andy mentioned that you wanted to go back and reference, we will be sending out a recording of this webinar to everyone who registered today. So thank you again, Andy, for your time, and thank you to everyone for registering for today's webinar.
Thank you, Jordan.
Thanks.